Hello. For this video, we will be answering this algebra problem from an online quiz bee that I hosted a few months ago. This question involves an arithmetic sequence. I think it's generally easy for most if quite familiar already with the properties of arithmetic sequence. But just for those who are not yet familiar or want to improve their knowledge about this, I'll share my solution for this one. So the problem goes like this. We have a sequence a sub n, which is an arithmetic sequence, and we are given that the ratio of the 41st term and the 25th term as 3 halves. We're looking for the ratio of s sub 100 and s sub 50, which is basically the sum of the first 100 terms divided by the sum of the first 50 terms. To answer this problem, we will use two important properties for an arithmetic sequence. It's that the common difference is common, so the nth term would be equal to a sub 1 plus n minus 1 times d. Using this formula and then iterating this, we have a known formula as well for s sub n, that is n over 2 times a sub 1 plus a sub n. You might also know that s sub n can be expressed as n over 2 times 2a sub 1 plus n minus 1 times d. Where basically we just substituted the formula for a sub n coming from the first one. So let's look at how to apply these formulas to the given problem. A sub 41 using the first formula is equal to a sub 1 plus 41 minus 1 times d. So that's a sub 1 plus 40d. Similarly, a sub 25 is a sub 1 plus 24d. Now, if we apply these two to the given equation, we have a sub 1 plus 40d over a sub 1 plus 24d is equal to 3 halves. We cross multiply, which is basically like the multiplication property of equality. We'll get 2a sub 1 plus 2 times 40d, that's 80d. Then on the right side, we have 3a sub 1 plus 24 times 3, that's 72 times d. We combine like terms, so the left side would be 80 minus 72d, that's 8d. And the right side would be 3a sub 1 minus 2a sub 1, which is just a sub 1. So we get here an important relation, that is the first term is equal to 8 times the common difference d. So we'll make use of this in our succeeding solution. So for this problem, there is no way that we can get a sub 1 and d because we only have one equation given. This is the only equation we have, and we have two unknowns, so there is no way that we can solve for a sub 1 and d individually. So the next step would be to try and evaluate the given ratio. So that's s sub 100 using the second formula that we have, that's n over 2, so 100 over 2 times 2 times a sub 1 plus n minus 1, I'm talking about this formula, n minus 1d, so that's 99 times d. But we know that a sub 1 is equal to 8 times d, which means that this thing here would be 100 over 2 times 2 times 8d, that's 16d plus 99d. If we simplify that, 100 over 2 is 50, and then 16 plus 99 is 115d. I suggest that we don't multiply this because we are looking for the ratio anyway, so some things might cancel out later on, so we keep it as it is. Then s sub 50 equals 50 over 2 times 2 times 8d, the same as what we did earlier, plus 50 minus 1, that's 49d. Again, I'll simplify that to be 25 times 2 times 8 is 16, plus 49 is 65d. Now, what's good about this is that both S sub 100 and S sub 50 are just multiples of d. So if we get the ratio of S sub 100 over S sub 50, we get 50 times 115d over 25 times 65d. Now again, as I've said earlier, we don't multiply out the terms first and look for factors that might cancel out. In this case, the numerator has a multiple of, or has a divisor of 25, so we can cancel that out, and in the denominator as well. So this becomes 2. Now 115 and 65 has a common factor of 5. So if we divide both sides, we get 23 here, and then 13 on the denominator. So we're left with 2 times 13 in the numerator, 2 times 23 in the numerator, and then 13 in the denominator, and that gives us 46 over 13 as our answer. So again, we use these two formulas, try to simplify, and then eventually we end up with 46 over 13 as our final answer. That's it for this video. I hope you learned something, and thank you for watching. See you on the next one. Bye-bye.